Madam, Madam mute.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for joining this session this morning. So we are in week number 2, and last week we have discussed on flexibility method, the introduction, the new term in flexibility method, and also the derivation of compatibility equation. And this week we will do a beam example, and so before we start with one new example, let's refresh the concept that we have learned last week. So okay, so in the module, some of you have got the module, right? Okay, basically all the things that I have explained last week based on this module. Okay, for example, this one, we refresh this first. Okay, so always remember that the goal, the objective, the outcome for flexibility method is to calculate unknown reaction, and we cannot analyze unknown reaction in indeterminate structures directly, because there are more than 3 unknown reaction, and only 3 can be determined using equilibrium equation. Means we have to have another equation to solve for the redundant. So that is why we have to use flexibility method, and the redundant we determine by solving compatibility equation. Compatibility equation is actually derived from the principle of superposition. Okay, so the compatibility equation is based on displacement, and in order to calculate displacement, we have to go through all the process, start from reaction, internal forces, and displacement, and then we put into the formula of displacement, then we will get the compatibility equation. Okay, so always remember that the compatibility equation is based on displacement, so we have to find displacement. We have to find displacement at the redundant position, So for example, this beam is subjected to 1 point load at the center. So roller at C is chosen as the redundant. CY is the redundant. So we will mark the delta occur at C for all diagrams. All diagrams including actual beam, primary beam, and redundant beam. So this is actual beam. So actual beam because of the roller. So delta at C, deflection at C is equal to 0 because it is roller. Okay, so here the primary structure where we have removed the CY, we remove CY. When we remove CY due to loading, due to P, so the beam will deflect. So we mark the delta at C. And we put the symbol. It is called as delta C naught. So delta is deflection at C, the first notation, delta at C for primary beam. Not is symbol for primary beam. So whenever we have delta, C naught means delta at position C for primary beam. Okay, then we will have redundant beam, same type. If a primary beam is cantilever beam, redundant beam also cantilever beam. Okay, if primary beam is simply supported beam, the redundant beam also simply supported beam. Okay, now we have the cantilever beam subjected to a unit value of CY. It comes from CY, but we have to change CY to 1 times CY so that we can analyze this diagram, the redundant beam due to a unit value of CY. So due to a unit value of CY, the delta is changed to FCC. So all redundant system, the displacement or the rotation we label as FCC. FCC. So FCC is displacement or deflection at position C for redundant beam due to a unique value of CY. Okay. So so this is the compatibility equation. We write from principle of superposition. We write from principle of superposition delta C in actual beam, delta C naught in primary beam, FCC times CY in redundant beam. Redundant beam is redundant CY applied. Redundant CY applied, and we apply the original condition in actual beam where at C is support. So at support delta C is equivalent to 0. So we finally write again the compatibility equation delta C naught plus FCC times CY is equal to 0. So this is actually the compatibility equation. So this is the compatibility equation. The compatibility equation. Actually, once we decide the redundant, CY is redundant. CY is redundant, then straight away we can get this. Okay, because in compatibility equation we will have displacement, and in redundant system, displacement in redundant system, we always have to times back with the redundant like this, FCC times CY. Actually this one is delta CC, and delta CC is FCC times CY. So this is condition where delta C is equal to 0 because of the support. Okay. Okay, now we will do one example. I don't want to solve this one. I want you to just try on your own. This is just one simple one span beam. This is quite straightforward, yeah, quite straightforward. So we will try another one. Let's say we have 3 span, A, B, B, C, C, D. Okay, so we try another example. Wait. So let's say we have this beam. Okay, fix at A. Fix at A. Okay, and roller at D. A, B, C, D, roller at D. So this is roller. Okay, this is roller. And then let's say this has UDL. Okay, this is 25 kilonewton per meter. 25 kilonewton per meter, and point load here. Point load. Okay, point load. So this is, let's say, 300 kilonewton. Okay, so we label this as A, B, C, and D. Okay, because from this diagram, we know that when we write moment equation, we have to have 3 cutting section. Comes from AB, BC, and CD. Okay, so this is indeterminate beam. Looking at the support, there are 4 unknown reaction. Looking at the support, there are 4 unknown reaction. So DOI, it is 4 minus 3. this is equivalent to 1. Okay, 1 redundant, 1 redundant, 1 redundant. So this is, let's say, dy as the redundant. Or if we want to use MA also can, MA as the redundant. So remember, if we choose MA, we remove MA. So the beam, the primary beam is the simply supported beam. Okay, so the redundant also simply supported beam. Okay, the redundant that we chose, we have to remove from the system. So actually, when we understand the derivation of compatibility equation, from this we can straight away have the compatibility equation, because compatibility equation is just the standard form of equation. So from this MA chosen as redundant, so we will have the compatibility equation, and the compatibility equation actually we derive from principle of superposition. So from principle of superposition, where the general equation is actual beam is equal to primary beam plus redundant beam. And redundant beam, we want to use the name of the redundant, MA as the redundant, so redundant MA applied. Okay, so this is based on the principle of superposition. We get the compatibility equation from this. Later on, we will determine displacement in primary beam. We will determine displacement in redundant beam. Okay, so from this we get actually the equation, the compatibility equation. Because we know that by solving the compatibility equation, we will get the redundant. So in primary beam, so the position is A, the position is A, right? The position is A, so we will label as A. So compatibility equation, because it is moment as the redundant, and always remember that moment with theta, moment curvature. Moment, the partner is theta. Moment induced rotation. So for the compatibility equation, we have to use theta, not delta. Delta is when P is the redundant. When vertical force, horizontal force, then we use delta. But for moment, we will use theta. So compatibility equation, so we have understand that when we write compatibility equation, we start with primary beam. So label displacement label in primary beam is theta. Okay, theta, position is A, primary beam symbol not. So this is displacement or rotation at position A for primary beam plus. Okay, so redundant, we always use F. Position A, redundant MA. So it becomes FAA. FAA times moment at A. And this is equal to 0. So we start from this. Because from this, we know that we will have to calculate two displacement. There are two displacement here. There are two displacement. Theta A naught and F AA. So there are two displacement. What is theta A naught? Theta A naught is rotation at position A for primary beam, and another one is deflection or rotation at A in redundant beam. Okay, theta A naught, the meaning of theta A naught. What is the meaning of theta A naught? This is rotation at position. At position A, rotation at position A for primary beam. Primary beam. And what is FAA? This is also rotation at position same, at position A for redundant beam due to a unit value of MA. Due to a unit value of redundant of MA. So that's the meaning, the physical meaning of theta A naught and FAA. So the formula, theta A naught, the formula, we will integrate from 0 to L. There are two M, MA and M naught dx. Okay, and we have FAA is equal to 1 over EI from 0 to L MA square. FAA means MA square dx. Okay, displacement. So whatever we do after this, the procedure, the step that we are going to take after this is actually to fulfill this formula. Because we know that we will get the displacement, the redundant. We want to calculate this redundant MA by solving the compatibility equation. In compatibility equation, there are theta A naught and FAA. Both are redundant and both are rotation. Both are rotation. So rotation in primary beam and rotation in redundant beam. Okay, so what is the formula to calculate this rotation? So theta A naught is integration, integration 1 over EI, we integrate MA M naught dx, and for FAA it is integration 1 over EI, integrate MA square dx. So what is MA? What is M naught? Always remember that M naught is the symbol we use for primary system. So inside this we have M naught first and MA. So what is M naught? Bukan MD ni. This is M naught. So M naught is moment equation. Moment equation for primary beam. And MA is moment equation for redundant beam. Redundant beam. So there are two systems right now. There are two systems right now. So this is the system. This is a system. So we have to analyze these two systems. Start from reaction, then moment equation, then displacement. Then only we substitute into the compatibility equation. So we will analyze start from primary beam. Okay, so we move to analysis of primary beam. So we move to analysis of primary beam. Analysis of primary beam. So analysis of primary beam. So in primary beam, okay. So let's say here 5 meter. This is 5 meter. This is also 5 meter, for example. Okay. So this beam, Okay, this is actual beam. Now we are going to analyze primary beam. So in primary beam, okay, so in primary beam, we remove moment at A, so we change fix to pin. We change fix to pin. So now it become pin support here. Okay, so we have pin and roller. It is simply supported beam. So having simply supported beam, can we analyze or can we calculate reaction at A? Okay, so we should be able to calculate reaction at A. Okay, so reaction at A for this beam is just like we analyze beam topic under solid mechanics, right? So we will apply equilibrium equation and then we cut the section to write moment equation. Okay, so in analysis of primary beam, we will get M naught. In analysis of primary beam, we will get M naught. So as usual, calculate reaction. Calculate reaction. So we will calculate reaction by taking moment at A is equal to 0. Okay, so actually reaction to get reaction for this beam, it is not compulsory we show because kejap. Hilang pula saya kat situ. Kejap. Okay. So reaction ni is just kita punya calculation untuk dapat. So you don't have to show. You do not need to show how we calculate reaction. Okay, tak wajib pun nak tunjukkan macam mana calculate reaction. So kalau simple you nak calculate outside dekat kertas lain and then just letak reaction value into the diagram also can. Okay, so what we want is just the value. Do not need to show the process, the how to calculate reaction. Because remember, learning outcome, back to the learning outcome, the learning outcome for this course. So showing the reaction though, showing how to get the reaction to is learning outcome when you learn beam for first time. Kan, students should be able to calculate reaction using equilibrium equation. That is not the learning outcome for this course. Kan? So showing students should be able to calculate reaction in determinate beam, in simply supported beam, in cantilever beam, semua tu adalah learning outcome in solid mechanics. So tak payah tunjuk pun calculation of reaction. Kalau you boleh dapat calculate reaction, buat congak je, dapat dah terus nilai AY and DY, proceed with the value directly without showing how we calculate the reaction. It is not compulsory to show. But if you still want to write because that is your calculation, then okay. Okay, so this is just we revise back the process, how we calculate the reaction, then we can write. Okay, for first time. Later on after this, we will directly put the value into the diagram. That is the most important. Okay, so taking moment at A, we have 25 times 5 times 2.5. We have plus 300 times 10 and we minus by, this is dy, right? This is ay. Okay, and we have we minus dy 15, 15 dy and 15. Okay, so having this, so we want to calculate dy. We want to calculate dy, so let's see what we can do here. Dia nampak tak? dy. Okay, sebab dia tak detect my tulisan Okay, so please calculate the answer for this. The answer for this dy. So calculate dy lah. dy is 25 times 5 times 2.5 times 300 times 10 times 10 we divide by 15 So what is the answer? Please calculate. What is the answer for this one?
222.83. 220, sorry.
220. Like this, Okay, kilonewton. Okay, 220.80. Okay, so this is a dy. So ay we have 5 times 5 plus 300 minus 0.83. So what is the answer for ay? The answer for ay, please. Please calculate for me. Come on, we have to go fast so that we can finish this example until the end. Please calculate 25 times 5 plus 300 minus 220.83. What is the answer?
204.17.
214.
204.
204.17
17.
kilonewton. Okay, so this is ay. This is ay. Okay, it means that ay is 204.17. This is 220.83. We have point load here 300 300, and we have UDL 25. This is 25 and this is 5 meter, 5 meter, 5 meter. Okay, so this is what I mean previously. So most important is this diagram. This is most important. This is compulsory lah. So this is compulsory. Yang atas ni not compulsory, but this is compulsory. This is not compulsory to show. Not compulsory, but this is compulsory. Okay. So this is important because from this we will write moment equation 1, 2, 3. So we have A, B, C, and D. Okay, so we will have 3 cutting section. We have 3 cutting section. So we want to write moment equation now. So in moment equation, this is M naught because this is primary beam. So in moment equation in primary beam, we have member AB. We have to decide the origin. Origin is A and limit of X is 0 to 5 meter. Okay, so this is the member AB, member AB. So yang ni put down. So X from 0 to 5 meter. So the section, okay, section AB, member AB, origin A, we draw this, okay, section to write the moment equation. And again, this is also not compulsory, but we do because we want to write the diagram. So kalau from this diagram, diagram, you can give the moment equation. So this step ni tak perlu breakdown lah, tak perlu tunjukkan. Okay, this is just to show the process. Okay, so we have here the section for member AB, origin A. Origin A means from A here, so this is origin A. So this is X. This is X, so we will write moment equation towards this diagram. Okay, towards this diagram, and the moment equation is taking moment at the cutting point is equal to 0. So we have negative M naught plus with 4.17 times X minus 25 times X over 2. This is equal to 0. So we get M naught is equal to 204.17x minus 12.5x squared. So this is the first moment equation. The first moment equation for member AB. So then we move to member BC. Okay, member BC. So for member BC, we have to choose origin that we like. And origin, not necessarily we start from A. So writing moment equation, even though for first time you learn about beam in solid mechanics, I can see from previous semester. So most of the student dia suka nak ambil moment tu origin tu semua from A. Actually it is not compulsory. In writing moment equation, please choose the easiest cutting section. So if for example for writing A as for writing member BC, moment equation for member BC, if you find that origin D is the easiest way, so just choose origin D. And actually origin can be A, can be B, can be C, can be D for writing moment equation. Yang ni yang selalu ramai confused. Not necessarily we choose A as origin. Okay, so for this case, I will choose origin which is come from right. Yang tadi bila kita cutting section at AB, we choose A because by choosing A as origin, it is the easiest. For BC, I think if we choose origin, come from right is easier than from left. So we can choose C as origin, or we can also choose D as origin. Both can be used. Okay, so let's say for member, okay, now we move to next member BC. So you have to write the origin name so that we know that you are referring to which origin. Okay, origin. You want D or you want C? Can, both can. Okay, normally kalau tak nak confuse, you pilih origin yang ada salah satu kat sini. Ini yang paling senang sekali. Kalau member BC, B can be origin, C can be origin, so that you punya limit akan always start from 0. Kalau origin is B, limit 0 to 5. Kalau origin dekat C pun limit 0 to 5. Okay, so this time I want to choose C as origin. So when C as origin, C tu adalah salah satu from B dengan C. So limit dia akan always start from 0 to 5. So X ni 0 to 5 meter. Okay, so now we draw the cutting section from, so origin now, here is 220.83 just now, 220.83 is the cutting section. Kita continue . Okay. Okay, so now C sini, D sini, right? Okay, origin C. Origin C means ini semua actually dia punya tricks dalam writing moment equation ya. Choosing origin. Origin is not necessary from A. Each point can be origin. A, B, C, D, mana-mana A, B, C, D tu can be origin. Okay, so for writing moment equation for member BC, ini yang paling mudah. Paling kalau you nampak mudah dekat D, you boleh choose D. Tapi when we choose D, origin, kita punya limit ni akan change. Okay, sebab origin kita ni dia akan, origin ni X dia 0. So now origin dekat sini. Origin dekat C. So what happen when origin dekat C means that sini 5 meter, sini X. Itu means origin dekat C. Sebab dekat origin ni, X akan start at origin. X will be started at origin. So that's why X tu, kita count X start from C. So macam ni X. Ini 5, ini X. Okay, ini 5, ini X. Berbeza dengan kalau D as origin. Kalau D as origin, contoh kalau D tu origin, D origin sini 220.83, semua boleh pilih, mana-mana tak kisah. D as origin maksudnya D X kat sini kan. The whole is X. The whole is X. So we will get here 5 meter, yang ni X minus 5. Nampak tak the different? Ini writing moment equation. And bila yang ni yang kita pilih, X limit ni bukan lagi 0 tapi jadi 5 to 10. Okay, that is why saya selalu bagi tahu student, okay, kalau you tak nak confuse dengan limit, so always choose origin. Kalau member tu BC, B or C as origin, your limit akan always start from 0. Tapi kalau macam ni, yang 5 ni C, 5 ni B. Tapi origin kita A. Sebab tu dia tak boleh jadi kosong. Okay, so yang ni yang biasanya saya jumpa ada kesilapan bila student buat lah, dia confuse. Okay, so kalau you tak confuse, you boleh je pilih A. Okay, but when you choose A, limit dia akan jadi 5 to 10, bukan 0 to 5. But when we choose B as origin, limit akan jadi 0 to 5. Sama juga kalau we choose B as origin, limit akan jadi 0 to 5 juga. Okay, so semua ni boleh. Okay. Okay, yang ni saya pindah tepi ya. Ini option. Option yang you ada lah. Okay, now we will write this equation. We will write this equation again, taking moment at the cutting point. Mx is equal to 0. So now this is m naught. Clockwise, moment clockwise, because origins come from right. Moment clockwise, origin come from right. So this is m naught plus 300x. 300x we minus by 220.83 x plus 5. X plus 5. Okay, x plus 5. So this is equal to 0. So we get m naught is equal to, kira lah. Okay, so kita dapat sini negative 300x minus 220.83x minus apa? Minus, ni negatif, ni jadi minus, okay, negative 300. Plus lah. Plus, negatif jadi plus. Okay, dua-dua negatif. So cuba kira je 220.83 times 5 dapat apa? 220 times 5. Please calculate 220.83 times 5. What do we get? Tolong calculate.
1104.15.
15. So simplify this. Kira balik yang ni x kan. So negative 300 plus 220.83 dapat apa? Dapat negatif
Negatif 79.17.
jadi positif kan. Negatif 79.17x ya.
Ya.
Betul lah. So tadi yang sana tu negatif bawa sebelah positif lah kan. Positif. Okay, so yang ni jadi plus 1104.15 So this is M not. So ini jadi moment equation for member BC. Kalau origin dia C, takkan sama dengan origin D ya. So equation ni setiap orang akan maybe akan dapat different equation. So cannot compare kalau origin kita different. Okay. Doesn't matter even though origin different, equation will be different. Okay, nanti ending dia, the displacement, we will get the same, the displacement, we will get the same value. Okay, so this is moment equation for member BC, origin C, limit is 0 to 5. Limit is 0 to 5. Okay, now last cutting section is member CD, so D is the easiest. D is the easiest for member CD. So member CD, origin D is the easiest cutting section. So C dengan D, origin D, so X akan start from 0 to 5. Okay, the cutting section is just like this lah, 220.83. Moment acting clockwise because origin start from right. So this is X. This is X because X ni dari sini. Okay, at origin X is equal to 0. At origin sini 0 So dia sampai sini. Sini D, sini C. So sini 5. So that's why sini 0 to 5. Okay, D from 0, D to 0. At origin X is 0. So yang ni direct je lah, simple, direct je. So this is M. So this is M naught. M naught minus 220.83x 0. So M naught is 220.83x. So this is M naught. M naught for member CD. M naught for member CD. So settle. Settle analysis of primary beam. Dah dapat moment equation M naught for all three cutting section. So now we move to analysis of redundant beam. Move to analysis of redundant beam. Analysis of redundant. Redundant MA applied. MA applied is redundant beam. Redundant beam. And this is MA. This is MA. Okay, so we draw the simply supported beam. We label A, B, C, D. And ada moment at A, yang ni MA ni huruf besar, MA ni huruf kecil. Okay, yang ni buat tulis kan. So yang ni M moment tu lah. Moment at A, reaction tu. Yang jadi redundant, moment at A ni M besar. Yang ni M small lah, yang ni M moment equation. Yang ni M ni moment equation, yang M ni redundant. Okay, lain cara tulis tu. Satu M huruf kecil for moment equation, satu M huruf besar for reaction. Moment at A. Okay, so we have simply supported beam, A, B, C, D, three cutting section. So we will apply a unit value at A. A unit moment at A. A unit moment at A. A unit value of MA. A unit value of MA. This is how the diagram looks like. Okay. So now macam biasa kita calculate reaction. So reaction ni Reaction ni 1 negative 1 positif lah kalau macam ni kan. So most important letak nilai. Letak nilai, tak perlu tunjuk reaction pun okay. But if you think that you still want to write because takut salah value, then go on. Okay, so this is 1 positive minus 15 dy kan. 15 dy 0. So dy sama dengan 1 over 15. Cuba check 1 over 15 in perpuluhan berapa? 1 over 15, 1 over 15. 1 bagi 15. Berapa?
0.067.
0.67. So dy ni is 0.067. So yang ni akan jadi negatif 0.067. Okay. So yang ni saya tak tepi je. Okay, because kita nak fokus kepada now three cutting section ya. Three cutting section 1, 2, 3. So cutting section yang ni as redundant, as come from redundant diagram, dia mesti follow primary beam. Kalau primary tadi kita cut 3 kali, so dia pun kena cut 3 kali. Kalau tadi pakai origin ACD, yang ni pun kena follow ACD. Kena follow. Okay, so have same cutting section. So for AB origin dia A, so limit dia 0 to 5. Okay, limit 0 to 5. So yang ni cutting section dia 0.067, moment counterclockwise sebab origin from left. So this is MA. So distance ini X lah. Distance ini X. So we get what? MA sama dengan negative 0.067x. So this is the equation. Okay. So we have member CD. BC panjang sikit kan? Okay, buat CD dulu. Okay, member CD origin D. So we get 0.067 moment clockwise sebab origin from right. So from here, okay, again sini dia punya distance X. So for the equation it is MA equal to 0.067x. So 1 negative, 1 positive. Yang ni positif lah. Okay, 0.067x for the moment equation. Okay, for member BC, origin sama tadi origin C. Limit also sama tadi 0 to 5. 0 to 5 dia punya limit. Okay, so diagram for BC. So we have to draw from D. 0.067. We have C and D. Cutting section here. Moment. This is MA. The moment equation. Okay. So distance sini. This is X. This is 5. Sebab origin kita from C. Okay. So for this diagram, we write the moment equation. So it is MA we plus minus 0.067, it is X plus 5, 0. Okay, so this MA is equal to 0.067x, bawa sana positif, right? Minus, bawa sana positif juga. Okay, 0.067 plus 5 berapa? Times 5, what is the answer? What is the answer? What is the answer? 0.067 times 5, please calculate. Come on quickly.
0.335.
0.335.
Yeah.
Okay. So this is moment equation ya. Moment equation. Okay, for redundant beam, we label as MA. Huruf kecil M for moment equation. So this is the moment equation. So this is what we should do. Okay, analysis of primary beam, analysis of redundant beam. So we actually calculate reaction in order to have moment equation. So step calculate reaction tu sebenarnya kita buat sebab kita nak tulis moment equation. Sebab without reaction, we cannot write moment equation for simply spotted beam. That is why we write reaction. That is why we calculate reaction. Okay, nampak tak? Do you get what I mean? Kita kan, saya ulang balik ya. Okay, so yang ni yang saya tulis-tulis ni semua nanti bila you jawab soalan, tak payah tulis. So this is just to show you I want to make sure you understand the process ya. Okay, so kita bila analyse indeterminate beam, for example macam ni, so dalam exam pun macam ni lah bentuk soalan ya. Cuma loading tu mungkin akan berubah nilai, mungkin akan ada tambahan loading, mungkin UDS jadi triangular load, something like that only. Okay, still macam ni, normally in exam memang dia akan jadi 3 member or sometimes 4 tapi jarang-jarang. Kalau 2 pun jarang-jarang dalam exam, so memang akan 3 cutting section dalam exam. Okay, sometimes 1 redundant, sometimes 2 redundant. Okay, kita nak solve for unknown reaction. The whole for unknown reaction cannot. So that's why we have to apply flexibility method. So when we choose to solve this using flexibility method, we have to choose redundant to remove from the system. Sebab kita dah faham yang kita tak boleh calculate unknown reaction directly. So when we choose redundant, we choose because we want to solve the redundant. So we choose redundant, we remove redundant, and we know that compatibility equation will be used to solve for the redundant. And compatibility equation is come from principle of superposition. So this is the principle of superposition. Okay, so sebenarnya after we have chosen the redundant, yang ni kita dah dapat, terus dapat. So understanding how we derive this, last week saya dah explain, dah boleh directly write the moment equation. Okay, so yang bawah-bawah saya tulis ni just for you to understand, tapi actually by looking at the symbol that we use, theta A naught FAA kita dah tahu dah, theta A naught ni adalah displacement, FAA adalah displacement. So ada 2 sistem sebab ada 2 simbol kat sini, ada A, simbol naught, ada 2 simbol. So naught for primary beam, A for redundant beam. Sebab naught dah ambil primary beam tu, A tu redundant beam lah. Kalau redundant dekat B, B lah. So dia berubah ikut position, redundant position. Okay, so these 2 displacement ada formula dia. So dalam formula tu ada moment equation. Again label dekat dalam ni adalah naught dengan A, naught dengan A. So naught tu for primary, A tu for redundant, MA for redundant. So kalau B dia berubah jadi MB, MC, MD. That's why dia ada satu standard form yang kita tukar redundant tu jadi 1, 2, 3. Okay, 1 redundant, M1. Okay, tapi for first example ni kita pakai simbol asal dia dulu lah. Okay, so that is why kita analyse primary beam and redundant beam. Kita analyse these 2 beams in order to fulfill the displacement formula. Sebab dalam displacement formula tu ada moment equation. Without moment equation, we cannot calculate displacement. Nampak tak? Setiap step ada meaning. Bukan hafal je 1, 2, 3 cannot. We cannot just remembering. We have to understand why we do this step, why we do this step. Okay, so we write moment equation because when from moment equation we can solve displacement. Sama juga bila kita buat reaction, bila kita calculate reaction ni, kenapa kita calculate reaction? Sebab kita nak tulis moment equation tu perlukan reaction. That's why we calculate reaction. So bukan saja-saja pergi calculate reaction because ada some case contohnya kan contohnya cantilever beam. Cantilever beam, kalau you tak nak calculate reaction, you ambil semua origin from cantilever end, origin tu from cantilever end, you tak payah calculate reaction pun tak apa. Tapi kalau calculate reaction, kalau dia simple nak calculate reaction, so that you can get Cutting section tu ambil from A dia akan jadi pendek, ambil from D dia akan jadi pendek. So you boleh calculate reaction. So dia bukan compulsory calculate reaction. Kita buat setiap step tu ada definition. Calculate reaction sebab nak tulis moment equation. Ada reason dia. Calculate reaction sebab nak tulis moment equation. Okay. Tulis moment equation sebab nak kira displacement. Nak kira displacement. Kira displacement sebab nak masukkan dalam compatibility equation. Faham tak? Semua ada maksud. Okay, writing compatibility equation sebab nak solve redundant. Okay, so calculate redundant sebab nak solve remaining reaction. Nak calculate reaction semua tu perlukan pada redundant dulu. So setiap step ada meaning. So kalau kita faham, kita buat ni each step ni ada justification dan boleh jawab justification tu means we understand. If dalam proses tu contohkan kita buat soalan and kita tak boleh jawab kenapa buat A, kenapa buat B, kenapa buat C, kenapa buat D, means that kita tak really understand. We just follow the flow. We just remembering. We cannot remember banyak nanti you takkan sempat nak remember everything. So please try to understand why we do this, why do we do that. That's why saya sebut, saya tak ingat dalam group mana, we have to set the goal first. We have to set the goal. That's why saya ada tulis summary ni kan. Saya tak ingat your group ke siapa punya group saya tulis. Kenapa flexibility method? Flexibility method ni, okay, sebab dia ada 4 unknown reaction. We cannot solve this for using 3 equilibrium equation. So we divide into 3 and 1. So 1 ni redundant. 3 ni tak apa. Dia boleh calculate guna equilibrium equation. Tapi satu ni dia jadi redundant. So how to solve this redundant? From compatibility equation. Itu yang ada compatibility equation tu. Delta 1 naught plus F11 kali redundant is equal to 0. This is compatibility equation. So dalam compatibility equation ada dua displacement. Ada dua displacement theta 1 naught dengan F11. Tadi A naught ni 1 naught ni the standard form dah. Okay, so dalam ni ada dua displacement. Ada dua displacement, theta 1 naught and F11. So displacement ni theta 1 naught and F11. So dalam ni ada moment equation. Dalam ni ada moment equation M naught dengan M1. M naught dengan M1. So M naught apa, M1 apa? M naught come from primary system. Primary beam. And M1 come from redundant beam. Redundant beam. So in order to have this, kita akan analyze reaction in primary beam, reaction in redundant beam. So every step ada penjelasan dia lah. So that's why kita kena set the goal. This is the goal. This is the goal. This is the objective of using flexibility method. Objective. This is the goal. Kita start daripada mana? Start daripada analysis of primary beam, analysis of redundant beam. Start daripada sini. Okay, start daripada primary beam, start daripada redundant beam. Start dari bawah. So di sini kita begin. Dekat sini kita begin. Step kita begin here. Goal kita sini. Ini kita punya goal, ini kita punya end. Okay, so always begin with the end. Begin with the end in mind. Nampak tak? Always begin with the end in mind. Bila kita mula buat analisis tu, kita mula daripada bawah. Tapi kita dah nampak dah apa yang kita nak cari at the end of analysis. Jangan kita start daripada bawah, kita remembering. One by one step we remember. Cannot. Engineer tak boleh semua benda nak remember. There's so many things to remember, we cannot remember. Always begin with the end in mind. That is why we start with learning outcome. That is why we start with course outcome, program outcome. Sebab kita nak tengok kita punya goal apa. Okay, so setiap step yang kita buat ada definition. Ada definition, so we have to understand that definition. Okay, so that lepas ni bila kita buat, kita faham why we calculate this, why we calculate that. Okay, so kita calculate primary, analyze primary beam, redundant beam because of this. Okay, because kita nak achieve kita punya goal, kita punya aim. Okay, so we have all the moment equation. So all this moment equation, kita akan basically kita buat table untuk summarizekan all moment equation. Member, origin, limit, M naught and MA. One is for primary beam, one is for redundant beam. So member tadi we have member AB, member BC, member CD. Origin kita A, origin C, origin D, limit 0 to 5, 0 to 5, 0 to 5. So yang ni kita pindahkan AB negative 0.067, negative 0.067x, yang ni 0.067x, yang ni negative 0.067x plus 0.335, and M naught tadi 22083x, 220.83x, and then AB, mana AB? Okay, ni AB. Yang ni AB Okay, yang ni AB. Kita kosong 2 tadi kan? Okay, so yang ni for AB, and for BC tadi, BC yang ni. This is for BC. Okay, so buat table bagi cantik lah. Okay, so buat table. Okay, table table. Okay, so this is summarize moment equation. So yang important table ni lah. Table ni is very important. Okay, because nilai-nilai ni kena betul supaya you dapat the right displacement. So lepas ni displacement lah. Displacement calculation. Displacement theta A naught and F AA. So theta A naught. Okay, theta A naught formula. Okay, please integrate. Actually, dia macam ni lah, 1 over EI from 0 to number 1, 5. Tapi, you tak payahlah tulis banyak kali. Tak payah pergi salin balik daripada table ke formula. Sebab tak perlu pun buat all the steps. Okay, yang important now is please integrate terus to 04.17x minus 12.5x square dengan negative 0.067 yang ni, integrate yang ni, and then put the limit 0 to 5, terus bagi jawapan dekat sini. Tak payah rewrite the equation. Kita buat one by one one by one. Okay, please integrate now. Integrate now M naught MA M naught MA 204.17x minus 12.5x square times with, okay, integrate together with negative 0.067x. The limit is 0 to 5. What is the answer in terms of EI? Tolong calculate jap. Please integrate. Cepat, jangan tengok saja. We have 20 in the class right now. Cepat, Andy ke, Nabila ke, Aina ke, Azwan ke, Azhari, Hakim, Amira. Integrate to 04.17x minus 12.5x square dengan negative 0.067x. Limit is 0 to 5. What is the answer? Berapa? Berapa? The answer please. Cepat-cepat, quickly integrate. Takkan nak kena tulis kot. 204.17x minus 12.5x square dengan negatif 0.067x. Integrate 0 to 5. Berapa nilai ni? Berapa nilai ni?
Negative
Negatif
439.12.
12 Okay. This is for AB, right? For AB kan? Okay. Okay, this for AB. Okay, next for BC. For BC, 0 to 5 juga. 7917x plus 1104.15 dengan 0.067x plus 0.335 dx. Berapa ni? Okay, tak payah tulis tau. Nanti tak payah tulis sebab kalau semua benda you nak tulis takkan cepat siapkan within the time given. Please skip unimportant step. So step yang penting table tu. Step yang penting ada diagram, primary diagram, redundant diagram and ada table yang dah siap ada moment equation. So step calculation, step writing moment equation semua tu tak perlu tunjuk pun tak apa. That is not compulsory to show. Sama juga when you want to calculate, when we calculate displacement like this, do not rewrite the equation into the displacement. Tak payah. Okay, terus bagi jawapan. You buat je. Terus tekan calculator, masukkan the moment equation and just write the answer. Ini semua tak payah. Tak payah tulis. Okay, so ni tak payah tulis. Okay, number 2. Now, for member BC, what is the answer? Limit is 0 to 5.
2221.64.
Apa? Depan tu? 221?
2 ada 3 2.
Dia positif or negatif?
Positive.
Positif.
664 only.
64. Okay, this is for BC. Okay, now yang ketiga is 220.83x. 83x dengan 0.067x 0 to 5 dx. So please integrate this. This is for member CD. Okay, tak payah tulis tau. Saya just tunjuk sahaja. Terus tulis dalam, terus tulis the answer for theta A0. Okay, now yang ni. Yang number 3.
.48.
616.48. Okay, then total. Okay, so total this. So this is theta A0. Okay, please total. Berapa? Dia sama je macam proses you analyze displacement in last semester unit load method. Okay, cuma label tu dia dah different label lah. Yang dulu M dengan M virtual, now M not dengan M redundant. Okay, M from primary system, M from redundant system. Same process. We adapt and adopt. So what is the answer for this theta A0? Just give in terms of EI.
2399 over EI.
2399 over EI. So this is theta A0. Okay, now we do the same for FAA. FAA, we just focus on this. FAA, we just focus on this. So please calculate, please calculate for AB 0 to 5, negative 0.067x squared dx. That is for AB. For BC 0 to 5, 0.067x plus 0.335 square dx, and for CD is 0 to 5, 0.067x square dx. Okay, give me the answer for the first one. Give me the answer for the first one.
0.187.
0.187. The second one. Second one, please.
$1.309.
309. The third one. Berapa?
Sama dengan yang first, 0.187.
0.187. Okay, 0.187. Okay, total please.
$1.683 of it.
683
Hmm.
over EI. Okay, now this is the displacement. Displacement, one in primary system, one in redundant system. Okay, so substitute. Substitute into the compatibility equation. Theta A naught plus FAA times MA equals to 0. Okay, so gantilah 2399 over EI plus 1.683 over EI times MA equal to 0. EI will be cancelled. So MA. Tadi 2399 positif ya? Positif eh? Okay, so we get MA equals to negative 2399 divided by 1.683. So we get negative moment. Ni moment capital eh. This is moment. Okay, dapat apa moment at A? So ni moment at A. MA is equal to, okay, please calculate negative 2399 divided by 1.683.
Negative 1425.43.
Kilo Newton meter. So this is the redundant. This is the redundant. Yeah?
2399 itu positif.
Yeah, because kita bawa ke sana.
Oh, okay. Sorry.
Kan kita solve kan, kita bawa ke sana, right? Okay.
Sorry.
So moment is negative 1425.43. Okay, dah dapat redundant. So dah dapat redundant means yang ni dah dapat. Ni dah dapat. Okay, ni dah dapat, redundant dah dapat. So kita tinggal lagi 3 remaining reaction. So 3 remaining reaction ni, actually once we have get the redundant, okay, we can solve using 2. Either we want to solve using equilibrium equation, can, or if we want to continue to solve using principle of superposition, also can. So ada dua option ya. So next is three remaining reaction. Reaction. Yang ni kalau you nak solve using equilibrium equation, you have to draw all again. So sini kan AY, DY, 300. This is 25. 25, dia 5 meter, 5 meter, 5 meter. And then we put the moment. So moment here is negative. 1425.43. So now we can calculate AY and DY. Sebab AX 0, right? AY and DY using equilibrium equation. So you akan dapatlah AY, DY dengan AX kosong. So then only complete. Okay, dah dapat all four unknown reaction. But we have another option yang lagi senang daripada kita calculate using equilibrium equation. We use the principle of superposition. Okay, back to the first thing I wrote sini. Actual beam, primary beam, redundant beam. Actual beam means yang ni yang kita nak calculate. So dekat sini kita ada AY dengan DY. AY dengan DY. AY dekat primary beam dah calculate. AY dekat redundant beam dah calculate. Gunakan this principle of superposition untuk dapat the value directly. Dia macam ni. Kita nak cari AY. So another option is by using, yang ni by using equilibrium equation. Or we can use principle of superposition. If we use by using the principle of superposition, okay, we have actual beam equal to primary beam plus redundant beam. Redundant MA applied. Okay, in actual beam we want to calculate AY. In primary beam dah ada AY in primary beam, and redundant in redundant beam also dah ada AY in redundant beam. But don't forget, in redundant beam mesti kali dengan MA. Kali balik dengan nilai MA tu. Okay, so in primary beam kita tengok the value tadi tu yang kita calculate tadi 2 something tu. Sini 204.17. 204.17 is AY in primary beam. 204.17. So sini 204.17 and AY in redundant beam yang negatif tadi tu. Negative 0.067 ni is AY in redundant beam. AY in redundant beam. Negative 0.067. Tengok sini diagram tu ada kat sini kali dengan MA. So negative 0.067 times MA. Macam ni. Times MA. So AY is 204.17 minus 0.067 kali dengan MA is negative 1425.43. 1425.43. Okay, this is AY. So we have two options now. Either we want to solve 3 remaining reaction using equilibrium equation by putting the value of redundant into the diagram and solve for AY and DY using equilibrium equation, ataupun kita boleh solve remaining reaction using principle of superposition, actual beam equals to primary beam plus redundant beam. Sebab semua nilai-nilai ni dah ada dalam primary beam, redundant beam tadi. Okay, so now sama juga for DY. For DY, sama je yang ni. Tapi now DY lah kali dengan MA. So DY in primary beam tadi tu 220 0.83 ke? DY tadi and 0.067, right? So this is for DY. So we get 220.83 plus 0.067 times with negative 1425.43. So then kita akan dapat the answer. Step dia memang panjang sebab kita kena go through all the process. Okay, start dari macam mana calculate reaction, lepas tu writing moment equation. Okay, so please give me the answer for AY and DY.
299.67.
Kilonewton. DY? DY?
192.326.
33 lah, kita assume 33 ya. Okay, kalau nak pakai 3, pakai semua 3 decimal point. Nak pakai 2, pakai semua 2 decimal point. Okay, kilo Newton. 192 192.33. Okay. So now dah dapat semua lah. Dah dapat semua. Okay, yang ni DY 192.33. Tadi tu 299.67. 299.67. Yang ni tadi 1425.43 ya. 1425.43 UDL 25 and this is 300. Cuba check. Dapat kosong tak? Yang ni. Bila kita check total fx kan. Actually we can solve remaining reaction using principle of superposition. Kita solve guna yang ni, lepas tu checking guna equilibrium equation. Sebab bila kita nak draw diagram, kita kena make sure the system is in equilibrium. Okay, dapat tak 25 times 5 plus 300 minus 299.67 minus 192.33, dapat tak kosong? Dapat tak kosong?
Madam, DY saya dapat lain.
Berapa dapat DY?
125.3233.
Sekejap. 125.33.
33.
Cuba check. Kita check for equilibrium check for FY. 0. Cuba check. 25 times 5 plus 300 minus 299.67 minus 192 ke mana 125 yang dapat 0? Cuba tengok.
125 dapat 0.
125. So 125 lah. Okay. So bila kita check dia dapat 0, then only we can actually draw the diagram. Because analysis memang kena sampai diagram. Shear force diagram, bending moment diagram. Okay. Kita nak practice juga nanti lepas ni nak guna lagi to knowledge bending moment diagram, shear force diagram. In this course and also after this in your design course. Kena tahu macam mana nak draw the shear force diagram, the bending moment diagram. Okay. Dapat ni ya, dapat kosong. Sama juga bila kita check moment, kita check for moment at A is equal to 0. Kita boleh check balik negative 1425.43 ni. Kita plus 25 times 5 times 2.5 plus 300 times 10 minus 125.33 times 15. Dapat tak 0? So bila semua dapat 0 means calculation kita correct, all the value is correct and the system is in equilibrium. Bila semua dah in equilibrium barulah kita boleh draw diagram and tepatlah diagram tu kan. Bila kita nak draw diagram, dia mesti close loop. Bila kita nak draw diagram, the system must close loop ya. Okay, now daripada sini actually kita dah boleh draw shear force diagram. Shear force diagram kita akan refer to the shear value and shear value kat sini is this value. Okay, shear value ini, shear value, shear value, shear value. Okay, so draw shear force diagram, just look at the shear value, start from 0, diagram start from 0, here is the starting point, end at 0, starting point 0, end point also 0, so starting point 0, so kita ikut arrow ni going up. Okay, and the value is 299.67. Okay, lepas tu kita jumpa 25 UDL times 5. We will minus. Okay, cuba kira 299.67. We minus by 25. 25 times 5. What do you get? Dapat apa ni? 299.67 minus 25 times 5. Apa nilai yang you all dapat?
174.67.
174. So dia satu line dengan ni lah. Okay, satu let's say point dekat sini. 174.77.
67. 6.
67. Okay, 67. Okay. Sekejap. So 299 tolak 20. Okay, bukan. Okay. 299 kat sini point dia. This is the point. Kita minus 25. 25 times 5 kita dapat 174.67. Okay. So now kat sini dia tak ada point yang naik. Okay, dia go straight je kat sini. Go straight sampai sini. 174.67 174.67. Sekejap, bukan ke 29, 25 times 5 dapat apa? 25 times 5? Yang ni dapat apa total nilai ni?
125.
125. So 299 tolak 125 berapa? Oh, dia dekat sini lah, bukan negatif kat sini ya. Dia bukan negatif, dia positif. So 174.67 atas. Okay. Dia bukan negatif, so dia dekat atas. Okay, so nilai point dia di atas. Yang first one is 299.67. Lepas tu 174.67 dia positif. Positif kat atas lah, positif. Okay, now dia akan go straight. Straight sampai 300. Jumpa 300 ni. Sampai jumpa 300. And then dia akan go down 300. Okay, means that 174.67 minus 300, what do you get? Yang ni. 174.67 minus 300, what do you get? Dia dapat 125.33. Dapat tak? Do you get 125.33? 174.300? Negative 125.33. Should be.
Yes.
Okay, so kita dapat point dekat sini. Okay, dia satu line like this. The value is negative 125.33. It is negative. It is negative. And now we plus back with the naik arrow dia naik atas kan. Sebab sini positif, dia arrow dia ke atas ni arrow ni kan. So tadi kita draw ni, sama tak kita follow the arrow. Okay, kita start from 0, arrow ni ke atas, so kita bawa dia ke atas. That's why point dia ke atas 299.67. And then we minus by 125. We minus by 125, kita dapat this point, 174.67. 174.67. So yang ni kita sambung these two titik lah. Oh, tak cantik, kita pakai ruler. Okay, so yang ni dapat macam ni. Yang ni tadi daripada 0 ikut arrow tu, ikut arrow shear, the first shear tu, AY tadi tu, dia naik atas. Okay, sebab tu dia duduk kat point atas, and then the minus 125 dapat 174.67. So 174.67 go straight sampai jumpa 300 tu, 300, and dia akan turun sebanyak 300. So dia turun 300. Okay, dia macam ni lah. So dia turun 300. Nilai dia adalah negative 125.33. So nilai dia. So dia akan go straight sampai jumpa D. Sampai D. Akan go straight sampai D. Okay, go straight sampai D. Sampai D. So dekat D ni nilai dia masih lagi negative 125.33. And then dia ada arrow positif macam ni. Arrow ke atas. So kita akan draw satu line ke atas. Ikut arrow tu. Draw satu line ke atas ikut arrow tu. And then dia akan end dekat 0. So nampak tak kat sini dia punya starting point. Dekat sini dia punya end point. So end point dia 0. Starting point dia also 0. Okay, so this is the shear force diagram. Shear force diagram for this beam. Shear force diagram for this beam. So semua ni positif lah. So this is positive, positive, negative. Okay, so this is A, B, C, and D. Okay, so this is the shear force diagram for the beam. Okay, from shear force diagram, kita tak buat dah macam you buat masa solid mechanic where you calculate the value of shear force using shear equation to draw bending moment diagram. Ganti nilai X, dapat moment value and then draw. Tak macam tu dah, because bila kita dah faham the concept of equilibrium, and bila kita dah ada complete reaction in the system, kita dah boleh draw shear force diagram. Okay, so this is how we get shear force diagram for this beam, and from shear force diagram we can directly calculate we can directly draw. From this kita akan draw the bending moment diagram from the area of shear force diagram. Okay, next after this is bending moment diagram. A dengan B tu trapezium. A dengan B trapezium, B dengan C rectangular biasa, C dengan D rectangular biasa. So now we will continue to draw the bending moment diagram. Sama juga bending moment diagram. Kalau calculation kita tadi betul, okay, kita dah check for total moment at total moment tadi. Total moment kita dah check dia dapat 0, then the diagram should be correct lah, and we will get 0. Mula dengan 0, end at 0. So yang ni saya continue. Okay, this is the line for bending moment diagram. Okay, so the first point, moment dia negative 142.5.43. It is negative. It is negative. Tapi mula dia bukan nilai itu, mula dia kosong. Mula dia kosong. Mula dia kosong. Mula dia dekat kosong ni ya. Mula dia kosong. Okay, kosong. Minus 14 to 5.43. Means point dia di bawah. So kat sini let's say dia punya point. So this is 142 2543. 2543. Okay, so for bending moment diagram start dengan 0. Okay, then titik kedua dia di bawah sebab dia negative 1425.43. Okay, now kita nak cari the next point. Next point is we have to look at the shear force diagram. Tengok pada simbol-simbol dalam diagram ni. Okay, kalau simbol dia positif, simbol positif means kita akan tambah area, tambah the area. Kalau simbol dia negatif macam ni, kita akan minus the area. Okay, so to determine next point at point B, kita akan tambahkan the area of this trapezium. The area of this trapezium. Okay, trapezium ni dia 299.67 dengan 174.67. The length, the distance from A to B is 5 meter. Okay, area dia berapa? Cuba kira area ni, area trapezium ni. Cuba kira area trapezium. Area trapezium is 1/2 kali 5, 299.67 plus 174.67. Ni kan area trapezium, right? This is the area of trapezium. Berapa nilai area ni? Berapa dapat ni?
1185.85.
1185.85. Ni area trapezium. Okay, so kita nak dapat point ni tadi yang now kita dekat stage 1425.43. We have to plus with the area of trapezium means that we have to plus with 1185.85. Okay, what is the answer? Kita masih dapat negatif. Negatif.
239.58.
239.58. So nilai moment dekat point B is 239.58, negatif juga. So at B ni, so at B ni, okay, the value, the point is somewhere here. It is 239.58. 239.58 and it is negative. It is negative. Okay. Okay, next area is BC. BC ni, BC, it is rectangular. It is rectangular, so it is just 174.67 and 5. Okay, yang tadi ni AB lah. Yang ni AB. Yang ni now BC. Area area. Area. Yang ni area. Okay, apa area BC? 174.67 times 5. What is the area?
873.35.
873.35. This? Betul
Yeah.
Okay. So next point means kita nak cari point dekat C ya. Kita nak cari point dekat C. Okay, kita nak cari point dekat C. So it is negative 239.58. Negative 239.58. And area tu dia tengok kalau dalam diagram shear force diagram tu dia tambah, so kita kena tambah. Okay, so kita tambahlah sini tambah 73.35. So kita akan dapat the next point. Okay, please kirakan. Dapat positif now.
Six three 3.77.
Okay, 633.77. So dia jauh ke atas ni kan. Okay. So nak pindah ke bawah lah. Sekejap saya pindahkan ke bawah. Okay, so assume that this is the point lah. Okay, it is positive 633.77. 633.77. Okay, now we have CD. We have CD. CD cuba check the area. The area of CD. Area CD. Area CD also rectangular. Rectangular 125.33 times 5. Cuba check yang ni nilai dia berapa. What is the area of CD? Area of CD
626.65.
6
to 6.
point
65.
65. Okay, jauh pula. Okay, sepatutnya dia kosong lah. Maybe macam ada tadi decimal point tu semua dia dia main peranan ya. So sepatutnya dia dapat balik nilai ni lah. Sebab dia tak ada moment dan dia patutnya zero. Okay, sebab lastly is 633.77 because kat sini dia minus area now. The area is negative means we have to minus. So sepatutnya dia 6. Dia tak lari jauh lah. Dia tak lari jauh. Kalau calculation kita ni cukup decimal places semua kita akan dapat the same value. Tapi kalau banyak kita bundarkan kan, so decimal places tu memang akan main peranan lah. So it should be the same value. Sometimes ralat plus minus 5 lah. Macam jauh sikit ni maybe yang contribute dia adalah apa decimal places yang kita ambil tadi. So it should be the same. Tapi this is the process lah. Should be zero. Maybe kena check balik some calculation yang ada nilai yang mungkin dia lari. Kadang-kadang dia dah start lari nilai tu bila kita ambil for example tadi kan 1/15 kita dah ambil 0.067 tu kan situ dah lari. Kan, so setiap yang action taken tu akan contribute lah. So kalau kita ambil kita buat dalam pecahan semua dia lagi accurate. Kan, kalau kita start ambil decimal point tu dia dah start ada gap lah, ada gap. Tapi the idea is titik last tu adalah sama, adalah zero. Sini zero. Okay, so kita punya diagram actually macam ni. Kita punya diagram. Okay, dekat the first one saja curve sebab dia UDL. Yang lain semua straight line. Okay, but yang ni dia straight line. Dia curve line. Dia curve. So this is bending moment diagram. Bending moment diagram. So bawah ni negatif lah. Bawah ni negatif, atas ni positif. Okay, so actually nanti from bending moment diagram ni lah kita akan dapat the shape of the display deflection in beam and the maximum moment yang kita dapat dekat dalam bending moment diagram ni yang tunjuk dia akan kat situlah kita akan letak besi semualah bila kita buat design nanti, design dalam subjek design lah. Okay, so this is how we get the shear force diagram and bending moment diagram. So analysis ni memanglah the course outcome, the learning outcome for flexibility method sampai kita dapat reaction. But still we have to understand that in structural analysis kita nak calculate the behavior of the structure. Okay, kita nak calculate the behavior of the structure. So the behavior of the structure kita akan calculate reaction, internal forces, displacement and displacement tu dia akan go back to the shear force diagram and bending moment diagram, because the shape of displacement tu dia bergantung kepada bending moment diagram. Macam mana bentuk bending moment diagram, macam itulah deflection yang berlaku in the structure actually. Okay, so memang whether it is determinate structure or indeterminate structure, we have to know until the shear force diagram and bending moment diagram. Okay, soalan kadang-kadang ada, kadang-kadang tak adalah. Normally dalam exam akan adalah satu soalan yang minta shear force diagram, satu soalan yang minta bending moment diagram. However, dia akan depend kepada time, your time jugalah. Tak perlu kira all macam ni, mungkin akan minta satu member only. Okay, but this is the process. So the whole process of analysis of indeterminate beam using flexibility method bermula dengan kita nak cari reaction dan akhirnya kita akan draw the diagram. Okay, this is the whole process of structural analysis. Okay, this is how we draw the bending moment diagram from the area of shear force diagram. Okay, kita dah tak write moment equation, actually it is the same. The area of shear force diagram tu sama je macam moment equation kali dengan X. Moment equation kali dengan X, so kita akan dapat balik, kita akan dapat the value. So this is the process. Okay, so the whole about flexibility method for one redundant is like this. So lepas ni dah boleh buatlah example lain. You boleh try dengan tukarkan nilai loading, tukarkan bentuk-bentuk loading. Okay, so that you boleh try variety of question lah. Okay, so untuk another 1 hour slot, saya akan ada dua benda yang saya nak cover. Yang pertama about the effect dalam this flexibility method that is called as support settlement yang akan actually mengubah nilai kosong kat belakang ni. Support settlement akan mengubah nilai kosong kat belakang ni. Tapi yang tu mungkin saya akan cover sekali dalam beam with two redundant. So another 1 hour, actually you pergi cari dalam video-video tu, video-video dalam my YouTube, yang saya explain how we derive the compatibility equation for two redundant, derivation of compatibility equation for two redundant. Okay, nanti saya akan bagi one question for you to solve macam ni lah, daripada mula sampai habis for your activity for this week. So remember 3 hours contact, this is contact hour, 3 hours contacts. Okay, means you have 3 hours SPT. Yang ni SPT. This is your side. So gunakan these 3 hours untuk buat soalan latihan ni. Dan one question you kena submit for formative assessment week 2. Okay, yang mana yang belum submit lagi, kalau ada yang belum submit formative assessment week 1, please do so. Because this week kita dah akan ada formative assessment week 2. Okay, so that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Good.